Welcome back. So now we're going to go through and remove the other variables, all of the other variables in the order that we think is kind of the least useful for a prediction variable to the more important. Okay, so we're at dt1, that's with knee removed. I've done drop term on dt1 and got this result here. And the least useful for prediction purposes variable is age now. It comes at the top of the table. It's got the lowest sum of squares here. So let's remove that. I'm just going to copy this code down to here. We're now going to work on dt1. So we're dropping a term from dt1. We're updating dt1 by removing age. And the new model, let's call that dt2. It does not contain two of the variables. Run those two lines. Run line 29, run line 30. We now have an AIC of about 1,410. So that's not a big difference from the previous one again. So not much has changed with AIC, which we would expect with what we saw with the drop term of age. Good. Now we can move on to the next one. dt2 is what we want to look at with drop term. So when we drop each of the variables, you see that biceps is the one that causes the least increase in the sum of squares and gives us an AIC of about 700. Well, this is the AIC, not uncorrected again, of about 717. Let's go ahead and try and remove that biceps then. We need to be working on, we need to be working on dt1 here, and we'll remove, what are we doing here? Oh, I'm in the wrong place. dt1, let's correct this. We're removing age, good, that is correct. Now we go down to here, we're working on dt2, change this to dt2, this down to dt3, and dt3, and we're going to remove biceps. It's easy to get muddled up here, as you saw me just do. So we will have a point in the end where we check to make sure that what we've done is all correct. 1,409, we're still very close to what we previously had. Let's do now dt3 we're going to work on. We'll drop from update dt3 to give dt4. And now what we need to do is see which variable we're going to remove. It's not going to be biceps because we've already removed that one. The next one at the top of this list, least important for predictive purposes, is chest. So let's remove that. AIC, oh, it's even better. AIC is improving because we're removing variables that are not particularly important for predictive purposes. Save. Good. Next one. We're going to be working with dt4 now. Creating dt5. And if we do the drop term, well, we're not going to remove the intercept. So the next variable we'd remove is ankle. Ankle. Remove that. AIC, still very good. Relatively speaking, AIC is only important in relative terms. Next one is we're working with dt5. dt5, creating dt6, getting the AIC of dt6, and we can't remove ankle. So let's get the next drop term. Height is the next one we remove. Good. Still looks very good. It's almost exactly the same as what it was before. So removing that variable hasn't diminished our predictive power according to AIC. We're now working with dt6, creating dt7, just there. Which variable do we want to remove? We run the drop term on dt6 and it's BMI. would you believe BMI is not that useful here for predicting percent body fat? Good. A very slight increase in AIC, nothing particularly great though. Let's continue. What we'll do is actually continue this until we get a variable with only the intercept, so we've removed everything. We expect that to be quite a bad model, but we're going to do it just for learning purposes. So now I've got 7, 7, working on creating 8 there. Drop term on 7. Hip is the next one we're going to remove. This sum of squares is getting a bit bigger now, so we might expect the AIC to start going up. Worse AIC. Let's create that. Well, not gone up so much. We're still plus minus 1 of where we were at in the lowest AIC. Let's now work on DT8, creating DT9. Drop term on DT8. Hip is the next one we will remove. Oh, I've made a mistake here. See, I've got 2 BMIs. Let's go back to the start. Go back to that model. Run DT1, DT2 creates DT2, DT2, DT3, DT3, DT4, DT4, DT5, DT5, DT6, DT6, DT7, and now that's BMI gone. Now this one should be hip here to give that one. Good. Now we're going to do that drop term again. So this time it's thigh. Perfect. DT8 thigh creates DT9. There we go. And that's DT9. 1409, still not too bad. Good, so let's get this. As you can see, it is relatively easy to make mistakes when we're going through it like this. So we need to check what we've done, as I said before. So we're doing the drop term on DT9. We're starting to get quite a small model now. DT9, DT9, DT10, DT10. And we're going to remove neck, because that is in here. Run. 1411. It started to go up now. The AIC's gone up a bit. So the model has got a bit worse. Not particularly bad still though. We were down at, so we were within 3 units of the best AIC. Now we're working on DT10. Creating DT10. Sorry, DT11. DT11. Now we need to find which variable. Weight. Now weight is responsible for quite a lot of the sum of squares, so it can account for a large amount of the variation in the data. So we expect to see the AIC go up quite a lot when we remove weight. And yes, we did. We're now maybe 30 units higher AIC, which is a lot. So this is definitely a big decrease in the predictive power of the model. Let's do the only variable that is remaining. Remove that to create DT12. Good. Run this. There's only one variable left, that's abdomen. When we remove that, we expect to see a big increase in the AIC. There we go, 1714. So the predictive power has gone down greatly. All right, so here's all the code we just written. It's a bit kind of repetitive. Knee, age, bicep, chest, ankle, height, BMI, hip, thigh, neck, weight, abdomen. That's the order that we removed variables in. And we created all of these DT 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which were the models with variables successively removed from them. Good. Let's just before we take a break, have a quick look at all of these models kind of in comparison to each other. To facilitate making that comparison, we will put all of the models into a list. DT2, DT3, DT4, DT5, DT6, DT7, DT8, DT9, DT10, DT11, DT12. Run that line, and now we're going to use a function called model.cell mods. It's only one L in cell. Run that. And we get this table. Let's try and make this a bit easier to view. I'll run that line again. Okay, it still goes over 2 lines, unfortunately. Let's zoom out just for the moment. And run the line again. Still over 2 lines. I will just zoom out once more. It's got a bit small for you, probably. This is the table summarizing these models, M1, DT1, DT2 through to DT12. How do we read this? Well, each row is one of the models. Unfortunately, it's not labeled by the model. We didn't name them. I'm going to correct that during the break and show you it afterwards, but just for now, we see that the best model is the one with delta AIC. That's the difference in AIC between the best model and this model of 0. And we can get down to here before there's 3 units of AIC difference, excuse me. And we get down to this point before we've got a model with more than 3 units of AIC difference. And actually that model contains just weight and abdomen. A couple of models here with relatively high AIC. You can see it's this model here, right down here, with 35 units of difference in AIC, and actually this does not contain weight. That's near as damn it 0, and so there we've got a big increase in AIC. Here an even bigger increase in AIC caused by removing abdomen. That's intercept only model. So it's a summary table of all of those variables. In this part of the table, in those rows, we have the coefficients actually. We're not so interested in those, we're more interested in the AIC and the delta AIC columns. Just to recap, the delta AIC column is the difference between the minimum AIC, which is that value, and the value in that row. So for example, this AIC here, the AIC of this model is 1408.9, and the difference between 1008.9 and 1008.4 is about 0.57 units. That's what's here. It tells us how much of an increase in AIC we have between this model and the best model. Okay, we'll continue after the break.